from P or Q, you don't know which, what's your probability of error? It's 2 to the minus n, where n is the number of samples times d. And then, finally, we have something totally out of left field, k of xn, which is the minimum length computer program over all computer programs P, such that when they're sent into the universal computer U, they print X. Okay, a word about all of these. First of all, h of x is not a function of the random variable x. It's this equation for the underlying distribution from which x is drawn, p of x. So why do we use this notation when it suggests that we're writing a function of a random variable when really we mean a function of the underlying distribution? Well, it'll come when we write things like the chain rule and so on. It becomes extremely evocative to write it this way, and similarly this way, rather than this other way. So I'll quickly give it to you. The entropy of 2 experiments is the entropy of 1 plus the conditional entropy, which I haven't defined yet, of the second with respect to the first. And that's less than the entropy of the first plus the entropy of the second. So you see, you automatically get a nice chain rule. The next term of everything you've seen before when you write it in this form. And that's why this notation is very useful. These all depended on some underlying distribution. Left field is itself. So what's going on? Why would this enter into information theory? Well, this was an important breakthrough by Chaitin, Solomonoff, and Kolmogorov at about the same time, because they've been searching for the notion of intrinsic complexity of an object. And so the idea was complexity is not the length of the sequence, it's the length of the short computer program. Zeros, that length is essentially 0. Strangely enough, if it's the bits of pi, there's a simple formula for that. It doesn't grow with n. That is, the programs just keep printing out the bits of pi. And so the bits of pi have 0 complexity. On the other hand, if I flip a coin n times, the sequence I get there has n bits of complexity. I cannot find a program. In other words, very small. I cannot find a program which will significantly reduce the length of the data from the one that just says print the sequence I've seen. So if I flip a coin 1,000,000 times, that's a sequence, and here's a program that'll print it. Print the following sequence. So the complexity of that sequence then is the length is certainly shorter than the program I just gave you. So the complexity is no greater than 1,000,000 bits. But it's no less either. And the reason is there aren't enough short programs to go around. So that will come up when we talk about Kolmogorov complexity. All right. Now I want to relate these things, show how they come up with the answer to various questions. Again, without being explicit about the definitions. So we have information theory here, and we have its relationship to communication theory. And here the things that come up are entropy, H, mutual information, I, channel capacity, C, HIC, I can't read it either, and so on. These are the fundamental limits you get in data compression, that's entropy, and in data transmission, that would be channel capacity, which is the maximum of the mutual information. So we have probability theory, and here we would have D, relative entropy limit D. H comes up as the answer to the problem of the asymptotic equal partition property, which is known in probability as the Shannon-McMillan-Bryman theorem. In statistics, we would have Fisher information, that's J of theta, and we also have relative entropy D. In economics, the intersection would be portfolio theory, and Kelly gambling, and you'll find a section on portfolio theory in one of the last chapters of the book, and a material on Kelly gambling, how to bet optimally on a horse race, and it's not well, it turns out to be proportional gambling, proportion to the probabilities the horses win, and doesn't have anything to do with the odds, as long as it's a super fair race. A super fair race means it's a fair race, or better than fair, in the sense that the sums of the reciprocals of the odds are less than 1. Economics. In math, you get, say, among other things, inequalities and the ergodic theorem. But just as an example, Hadamard's inequality says the determinant of a non-negative definite symmetric matrix is less than or equal to the product of the